Welcome to Unit 3. In our last unit, we went over the definition of the derivative, and we know that we can calculate derivative by directly applying the definition. In this unit, Unit 3, we're going to look at various patterns, we call them derivatives rules, that helps us calculate derivatives more quickly. This is use lesson 1, which is part 1. Here's some examples. Let's see if we can figure out the pattern. If a of x is x to the third power, the derivative a prime of x is 3x squared. If b of x is x to the fourth power, then the derivative b prime of x is 4x cubed. Well, if c of x to the fifth power, what do you think the derivative is? Well, we see that the 3 just came out front, and then 3 turned into 2. In the next one, x to the fourth, the 4 comes out in front, and then the 4 turned into a 3. If we apply the same pattern, the 5 will come out in front, and then 5 minus 1 is 4. So the derivative of x to the fifth is 5x to the fourth power. We can generalize this. So for x to the any power, to the nth power, the n is going to come out front, and then the power is going to be n to the n minus 1 power. To the n minus 1 power. So if f of x equals to x to the n power, f prime of x is nx to the n minus 1 power. By the way, these examples I gave you, x cubed, x to the fourth, x to the fifth, in the enrichment video, we will prove all of these, so that all of these are true, by applying the definition of the derivative, and we'll also prove this general rule. But for now, let's apply this rule. So we know that the derivative is nx to the n minus 1. Alright, if m of x is x to the 8th power, then the derivative would have to be the 8 comes out in front, and then 8 minus 1 is 7, so the derivative is 7. So the derivative of x to the 8th power is 8x to the 7th. Example 2, n of x equals x squared. Alright, well, for this one, again, follow the same pattern. The exponent comes out in front. The derivative, the exponent, the power goes down by 1. 8 becomes 7. For this one, it's x squared, so 2 becomes 1. So it's 2x to the 1 power. Of course, that's just equal to 2x. So the derivative of 2x, the derivative of x squared is 2x. Last one. P of x equals to x. What's the derivative? Some students might get confused at this point. But remember, x is just the same as x to the 1 power. Therefore, our derivative has to be p prime of x is just 1 times x to the 0th power. That's 1 times x to the 0th power. Of course, 1 times anything is itself, so 1 goes away. Any number to the 0th power is 1. So this is 1. So the derivative of x is just 1. That makes sense. If we have a line, y equals mx plus b, that's the same as m being 1. So the slope of px equals x, p to the x equals x is just 1. Okay. A couple more examples. K of x equals 1 over x. Remember 1 over x can be written this way. What really helps us is to remember that 1 over x is the same as x to the negative 1 power. So now we can apply the power rule. It works the same way. K, the derivative of k prime x. Well, if the power is negative 1, the negative 1 comes out in front. Negative 1 minus 1 becomes negative 2. So the derivative of 1 over x is negative 1 times x to the negative 2 power. And that's equal to negative 1 over x squared. Okay. Last example this time. So 1 over x to the fifth is our function. Q of x equals 1 over x to the fifth power. I'm going to write as a fraction 1 over x to the fifth power. Of course, that's the same as x to the negative 5 power. In other words, we know that the derivative q prime of x has to be negative 5 x to the negative 6 power. Because negative 5 becomes negative 6. You can also write it as negative 1 over, sorry, it's not negative 1, it's negative 5 over x to the 7th power. Not 7, 6. Negative 5 x to the negative 6 power is negative 5 over x to the 6. Okay. To get to the next rule, let's go back to what derivative and intercept means. So real quick review. Example. Elena makes $30 an hour and has $50 right now. Wideline makes $40 an hour and has $20 right now. We're going to write expressions for Elena's money, Wideline's money, and the total money. So Elena makes $30 an hour and has $50 right now. So using slope-intercept form, we know that slope is our rate of change. So that's the slope, and that's the y-intercept. For Wideline, that's the slope, and that's the y-intercept. In other words, Elena makes $30 an hour, that's the slope, 30, let's call it 30x. Has $50 right now, that's the y-intercept. So Elena is 30x plus 50. Similarly, Wideline will be 40x plus 20. Well, in total, at the beginning, Elena has 50, Wideline has 20, so it's got to be plus 70. If Elena makes $30 an hour and Wideline makes $40 an hour, then in total, they make $70 an hour. So the slope will be 70. So the key takeaway is we see that if the slope of the first function, really this is an expression for now, but we can write it as a function, is 30, and the slope of the second one is 40, then the slope of the total function is just 30 plus 40. The slope is just the sum, the slope of the total is the total of each slope. Okay. So if we look at some examples, if p of x equals x to the fourth plus x to the seventh, then the derivative is just going to be, well, the derivative of x to the fourth is 4x cubed, 4x to the third power. And then we have the second part plus the derivative of x to the 7 is just 7x to the 6th power. Or we can write it this way. So that's it. The derivative of x to the 4th plus x to the 7th is just 4x cubed plus 7x6. Subtraction works the same way. If we have x to the 3rd power minus x to the 5th power, then the derivative is just 3x to the 2nd power minus x to the 5th. The derivative of that is 5x to the 4th power. So if we see addition and subtraction, we can just subtract right at the derivatives. One more. Back to the slope review. If Juan makes $40 an hour and has $70 right now, Maria makes 3 times as much money and has $100 right now. 3 times means times 3. So we know that Juan is going to be 40x plus 70, because 40 is the slope, 70 is the y-intercept. Maria makes 3 times as much money per hour. To be clear, I'll write per hour, an hour. If Juan makes 40, that means Maria makes 40 times 3, which is 120. She makes a lot of money per hour, and she has $100 right now. The important takeaway is if our function is multiplied by 3, then the slope is multiplied by 3. And that's true for any number. So the general rule, if f of x equals c, where c is just a constant multiple, times a to the x power, by constant multiple I mean a number. So if f of x is c times a to the x, then f prime of x is c times f prime of x. To be more clear, here's an example. Well, we know that if a of x, then a is x to the third power, then a prime of x is 3x to the second power. Okay, we know that from earlier. But what if b is not x cubed, is 7 times x to the third power? We have that 7 then. Well, that's simple. The derivative, so if bx is 7x to the third power, b prime of x is just, the 3 comes out in front, times x, and then to the second power, because originally it's the third power. 3 minus 1 is 2. What's 3 times 7 is 21. So the derivative of 7x to the third power is 21x squared. Okay. 2 final examples, and that's it. Example 1. b of x is 6x to the fifth power plus 4x to the third power. 6x to the 5 plus 4x to the 3. Then the derivative, well, 6 times 5 is 30. X, 5 minus 1 is 4. So it's 30x to the fourth power. Plus 4 times 3 is 12. 3 minus 1 is 2. So the derivative of 6x to the 5th power plus 4x to the third power is 30x to the fourth power plus 12x squared. Example 2, we have a quadratic here. 5x squared minus 3x plus 8. Again, we do each term individually. 5x squared turns into 10x. Minus 3x turns into negative 3. Because remember, x is the same as x to the 1 power. 1 minus 1 is 0. Plus 8. Well, that's a constant. There's nothing here. One way of looking at it is 8 is the same as 8x to the 0 power. When we take the derivative, 0 comes out in front. 0 times 8 is 0. That's why the derivative of 8 is just 0. And the derivative of 5x squared minus 3x plus 8 is 10x minus 3. Okay, that's it.